Okay, it's just about 11 o'clock, so it's still the morning. So I'm saying good morning, and we're continuing with our diodes and their application. So we're looking at the use of a 6-diode switch as a multiplier. In previous classes, we had looked at the 6-diode array and also the 4-diode array used as logic switch. Now we're going to see how it is used as a multiplier, phase detector, and a mixer. Or let's draw the diagram of the 6-diode switch, which is the same as used for the 6-diode multiplier. For diode, let's see what we're going to have so much. So inductance coiled in 1:1 ratio. This is grounded. Call this D5, diode 5. This is diode 6. RC 4.7 kilo ohms, 6 volts up there. Minus 6 volts down here. RC equals 4.7 kilo ohms. Diode 6, diode 1. Say here for the voltage VC equals V on or V off. So yeah, so this is the diagram of the 6-diode switch. Uses a multiplier. Now if we let VI equals V equals now sine 2 pi FCT. And if we let V control VC equals now cos 2 pi FC. Then if we assume that the switch turns on or off when VC goes to 0, turn on or off when VC goes to 0, then the control signal will switch VI on or off at a rate FC. I know we choose 20 FC to demonstrate the multiplying effect, F5 equals 20 FC. And here's now the diagram. FC equals 20, Fi equals 20 FC. Mix. V in of T and V out of T. And this is S of T. Minus T by 4 0 t by 4, 3 t by 4, 5 t by 4. Now to demonstrate the multiplying effect, we choose Fi equals 20 Fc. And we let Vi equals sine 2 pi Fc of t and Vc or cos 2 pi Fc. And this is the 6 diode switch, which is the same diagram for the 6 diode multiplier. Alright, let's see which one of these diagrams we should remove. Now for the diode, switch at the multiplier. I'm just going to use this sign for multiplier right now. We have now Vi of t equals sine 4 pi 10 to the 7 and Vc of t equals sine 2 pi 10 to the 6. Now the switching operation is best represented as follows. The sinusoidal control voltage of frequency Fc is replaced by the square wave switching function S of t and of frequency Fc, which is either 1 volt or 0 volts. Now when S of t is 1 volt, when 1 volt, we have VL equals VL of t. And when S of t is 0 volts, VL equals 0 volts. And since S of t is periodic, it can be represented as a Fourier series. Yes, since S of t is periodic, it can be represented as a Fourier series. Let's write down the Fourier series here. Talking about S of t equals 1/2 plus summation n equals 1 to infinity of sine n pi over 2 over n pi over 2 cosine 2 pi Fc. Right, thus VL of t is equal now to S of t, Vi of t, or VL of t, that's equal now to 1/2 Vi of t plus summation let's write this below here. Sine cosine 2 pi So then this equation shows now that VL of t consists of the original signal Vi of t and the product of the two signals, and product of Vi of t and harmonics of the original control signals. Now if the switch is followed by a tuned circuit with center frequency f of c and bandwidth B equals 2 Fi, the voltage at the input of the filter will be VL of t equals now sine 2 pi Fc t cosine 2 pi where k is some constant. And thus the control output voltage V L of t is proportional now to Vi of t and Vc of t. So this is proportional to Vi of t, and then we say now that VL of t equals some constant Vc of t Vi of t. No, the circuit that I've just drawn with the square wave and the periodic sine, and the circuit in combination with the 6 diode array logic switch, which is the same diagram for the multiplier. The circuit has several names depending on the design objective. If we intend that Vn of t equals, if we intend now, if, a piece of chalk here, if we intend that VL of t equals now sine, or rather S of t, Vi of t, then the circuit is operating as the multiplier. That is, VL of t equals S of t, Vi of t. And that is the multiplier effect. Now, if f of I equals f of c, and it is a phase shift theta, between Vi of t and S of t. Now, if VL of t is low pass filter, then the output of the filter is proportional to sine theta. So the output of the low pass filter will be proportional to sine theta. And plus we have the phase shift now. The circuit is now operating as the phase detector. output voltage VL of t is followed by a tuned circuit center frequency NF of C. Then the circuit is called a mixer, and we say that it is shifted or heterodyne to the frequency Fi plus NFC. So it is shifted from F of I to F of I plus now NF of C, and we said it is shifted or heterodyne to this new frequency. So there we have it. We have now the 6-diode array, which is a 6-diode array logic switch. Now turn into a multiplier, and then we see it operating as a phase detector and as a mixer. Alright, we're going to take a look at a special diode, at the Schottky diode and then the Zener diode.